Welcome to Woke Talk Podcast. I'm your host, Sam Stanford. As a physicist and structural engineer in training with Jacobs Engineering, I've made many connections with some bright individuals who are either working, studying, or self-taught and passionate about our particular topics of discussion. Today's topic focuses on building materials. These building materials pertain to the materials we utilize in the built infrastructure here in the United States and globally. So throughout the episode, we are going to discuss the current materials that we know and love, the materials that are up and coming, and then we will end the podcast by going over how building materials and their codes can help us battle climate change. Now, I'm very excited about this episode because it deals with the materials that structural engineers, like myself, utilize to develop our built environment. Since I am only a young Padawan, so to speak, I reached out to a former professor of mine, Dr. Harries. He was delighted to be on the show, and he invited me to sit down with him in his office at the University of Pittsburgh for this interview. Now, bear in mind, this is our very first interview that took place outside of a Zoom call, and due to a few parameters, we were only able to capture a video file for just this intro and the closing statements. But nonetheless, the show must go on. Now, let me introduce Dr. Harries. So Harries is a professor of structural engineering and mechanics at the University of Pittsburgh. Dr. Harries has over 30 years of experience in structural design, especially the use of non-conventional materials in civil infrastructure. He is also deeply involved in codes and standards development and having chaired both national and international code committees. So Dr. Harries has been actually elected a fellow of the American Society of Civil Engineers, the American Concrete Institute, and the International Institute for Fiber Reinforced Polymers Council. Last but certainly not least, he is a licensed professional engineer. And just as a fun fact, as a Canadian, Dr. Harries continues to play ice hockey. So he stated, and I quote, "All my teeth are mine and they have been paid for." So stick around, because when we return from our first commercial break, we will begin segment 1, where Dr. Harries and I plan to address the building materials that we have come to know and love. Here we are, segment 1 for Materials of the Future, featuring a former professor of mine, Dr. Harries. Now, first of all, I'm very happy that you took the time to be on the podcast, so thank you. Now, I know it has been a few months since we last conversed. So what have you been working on in terms of research or in regards to these building codes?
Accessibility to building codes, particularly aimed at non-conventional materials, at new materials. None of us really think we're going to change the concrete or steel codes anytime. But these emerging codes, we have this remarkable opportunity to really impact how they're designed, how they're built, the codes now I'm talking about, and then therefore how they're used much more internationally. If you put together 500 pages on bamboo, it's just going to get shelved and never used. So we just came out in June of this year, the ISO design code for bamboo, and it was actually adopted the same day ISO released it. Happened to be the day of the meetings at the British Standards Institute, and they adopted it the same day, and it's now for sale as a BSI document as well.
Wow, that's fantastic. This first segment, I kind of want to get into laying the groundwork for the rest of this episode, and we are going to maybe paint the current status of materials we use in the built environment. You know, in my short time studying and working in the consulting side of infrastructure, I always notice the same kind of 4 materials, and you can correct me if I'm wrong. And I'm sure you can also expand on these, but they are wood, concrete, steel, and asphalt. The American infrastructure had an estimated construction and demolition count of up to 600 million tons of materials as reported by the EPA in 2018. That is actually just only 1 year alone. And since then, it has only increased due to population, aging infrastructure, and cultural demand. The vast majority is diverted to next use, but a still strikingly large percentage is landfilled. So in regards to the 600 million tons of materials seen in a year's time, the vast majority is those 4 materials, but not including virgin aggregate. We have to recognize that aggregates still concentrate in asphalt and concrete. But nonetheless, why do you think we cling to these materials?
Because they do the job that we're asking them to. They've been around. I mean, concrete is something that would easily be recognized as concrete. It's been around for 2,400 years and plus. Portland cement, the actual material that we use, the cement that we use has been around for 170 years now, something along those lines. I've forgotten my dates exactly.
Just to add on to what Dr. Harries said, we've been using cement and concrete since 6500 BCE, but although this building material was lost through the Dark Ages, we reestablished usage post-Enlightenment and have been using it ever since with exponentiating terms. It was John Smeaton, a British engineer in 1756, who actually developed the first modern concrete, and we've been using it and developing it ever since. Then came along Francois Coignet. He published one of the first concrete code books in 1861 for reinforced concrete that captured many applications. Today we have national codes for concrete and internationally accepted codes as well. ACI, the American Concrete Institute, is a national code that we use here in the US, and the IBC is published by the International Code Council and or the International Building Code.
The Iron Age came about again, sort of ended about 3,000 years or 2,000 years ago. And something that we recognize as steel, the Bessemer process came around in about 1860. These are well-established materials. They use very, very, very inexpensive raw materials, which are abundant. I mean, despite the cost, iron ore is not that difficult to come by. Much of our steel, certainly in the construction world, is recycled.
Just to build off what Dr. Harries was saying, steel did come into the picture much later, around the 1860s, at least here in the United States. But most forms of ferrous metals being used were wrought iron and cast iron. The dawn of railroads actually projected the study of metallurgy, which brought us to the many varieties of steel that we use today. Chicago was actually one of the first to build a building skeleton made of steel in 1885. And the American Institute of Steel Constructions, or AISC, published their first codebook in December of 1927, giving us almost a century of learning curve in steel design and construction.
Aggregate is everywhere. Yeah. Sand is everywhere. Appropriate materials. Asphalt is something I'm not as versed in. It's basically used for road, and I don't do roads. But other forms of masonry, clay brick, things like that are certainly also in the big group. Clay brick in particular, obviously, is used an awful lot, not as much for structural application, but for facades and what have you. And of course, it's a hugely energy intensive product along with the rest of these. And of course, wood is not as renewable. It is a renewable product, but it is not as, it needs to be managed, right? Put it that way. And so it will never overtake. We can certainly build 20-story, 30-story buildings out of wood. There's a project planned on paper, at least, for about a 70-story wood frame.
Where's that?
Structure in Scandinavia.
Okay.
Go figure, in Scandinavia. But the reality is we couldn't possibly make that the norm because we just don't have the resource. And at the moment, managing a resource to that extent is not practical.
Right.
Why are steel, and I'll stick with steel and concrete, but why are they so prevalent is because they're cheap and they're easy and they work together. Right. This is one of the things that we need some compatibility. You can't really, building a steel floor doesn't make a lot of sense, but concrete and steel work together when you support a concrete floor on a steel framing or something like that. It's also what we know. Don't underestimate the power of your education. What classes did we teach? Steel design and concrete design. Yep. So we're wagging the dog. We're saying, well, this is what you can do. So people go out, they're going to use what they're comfortable with. When you go into other areas of the world, developing areas, they look to aspiration. And so what do I aspire to have? I aspire as somebody in the developing world to have a concrete and masonry house. I don't aspire to a timber house, and I certainly don't aspire to bamboo because bamboo is for poor people. That's wrong. Yeah, but that's sort of how our society has framed this problem, right?
Very true. So what's your take on government? How do you think government works with these materials?
Well, there is, just out of the sheer fact that the largest contractor on the face of the planet, and I'm not exactly certain this is true, but is certainly a government, and it's likely the US, it's actually likely the Chinese government, excuse me. But yeah, government in pretty much every nation is going to be your largest single builder. There's a reason we're called civil engineers, right? I mean, civil is being the opposite of military. Right. We build, one of the best definitions of infrastructure I have ever heard is those things that are just too big for one person or one company to do. And that gives it a slightly different spin. And so that's the role. So then government is simply, I mean, it's hard to say that they're directing one way or the other. They're not, at least in this country. We don't have, oh, we're all going to do steel because we've got to prop up the steel industry or concrete. We don't have any of that going on.
I think it kind of goes a little hand in hand because we still use we use coal and oil and also their byproducts to make these materials. So it's just kind of like, well, we have all this byproduct, we have all of this mined non-renewable resource. So let's put it to work to keep people in work, and we know it works. So let's kind of stick with it. I think the way we value energy greatly correlates with how much our infrastructure utilizes this material, along with other factors. But it's just kind of like a correlation, I guess, in between what you say is, the government has to do it because no other private enterprise can, but then also goes a little hand in hand with how we go about things in terms of energy.
I mean, yeah, you can't separate energy from the mix. There's no question, because you need energy for these materials. And actually, most construction materials tend to be energy intensive.
Yeah.
And again, that's because they're relatively cheap. We think about them as energy intensive, but the reason is more so it's because we use so much of it rather than that they're inherently energy intensive themselves. If you talk about a per kilo basis or something like that, it's just that we use so much of it that it becomes a massive drain, as it were, whether it's on energy and or any other way you want to measure resources. And it doesn't have to be just energy. It can be carbon emissions, because you can certainly generate a great deal of energy with very few carbon emissions. There's certainly some in the process of building wind turbines, and there's certainly a lot of energy used in the process of building a nuclear reactor or something like that. But energy alone is not a reason to move away from energy intensive. If we could have a different portfolio of energy sources, then why not?
I think you hit the nail on the head there. I guess my last point I would like to hear before we end this segment is it's kind of in relation to consumption. So how much do we use in concrete, steel, wood, and asphalt individually? I know you touched upon the kind of the holistic idea of material consumption, but what comes to your mind, like whenever you think individually?
Oh, I mean, I teach this stuff, and as a good instructor, I could pull up nice slides and show you the data. In fact, one of the best books that does this, it happens to be at home right now. It's not on my shelf here. The consumption is massive. If you think of concrete roads, bridges are a really small little part of it, but the actual road themselves.
Right.
If you think of aggregate, for every road or every mile of road, you not only have 8 or 10 inches of concrete, you may have 18 plus inches of crushed stone underneath that,
right,
or more. And steel also is one of the largest by weight industrial products that are made.
This is absolutely true. Steel produced globally was estimated in 2020 to be about 1.86 billion metric tons, and the U.S. only contributed 72 million metric tons of the 1.86 billion. Meanwhile, the U.S. does nearly recycle 70 million tons of domestic steel scrap for the production of new steel, and that is nearly a 100% recycled market for the built environment. While steel industry has a heavy footprint globally, it's actually estimated that the concrete industry nearly doubles what the steel footprint is, and it's estimated to be about 4.83 billion metric tons by 2030.
There's an interesting thing that I show my students in a class on non-conventional materials, is that when we started out as a species, we used absolutely no engineered materials. We relied entirely upon what we would be able to find in nature and whatnot. And today we've gone to the absolute other extreme. We essentially only use engineering materials. Yeah, you could talk about 1 or 2%, maybe not. But that transition was actually very, very shallow through most of our history until the Industrial Revolution.
Right.
So middle of the 19th century. And then all of a sudden that consumption just takes off. And like I said today, I mean, 99%, I would assume in that vicinity of what the materials that we use are engineered materials. And therefore there's energy input into their fabrication.
Yeah, well, perfect. We have to take a short break, but when we come back, Dr. Harries and I will be discussing some of the materials that we feel are going to shape the way we design our infrastructure. So stay tuned. Welcome back to the second segment of Materials of the Future. This segment is the introduction into some exciting building materials that you may or may have not heard of or even thought of. As I mentioned in the introduction, not only is Dr. Harries a licensed structural engineer, he is also an expert on materials. So, Dr. Harries, what materials come to mind when you think of futuristic building materials?
Bamboo is my hobby. We've been doing a lot with bamboo, largely because it represents a very viable alternative for potentially on the order of 1 billion people on the face of this planet that live today in what we call informal housing, whatever that may be. In India, we call them slums. In Brazil, it's the favela. In the townships in South Africa and what have you. And the massive numbers of people, and the numbers are all over the map, but it could be as high as 1 billion people, probably a little bit lower, that will be impacted in the next, could be 10 years, could be 50 years, due to issues like sea level rise.
Thinking like 13% of the total population. It's massive.
And it's not clear. Obviously, there's a lot of uncertainty there, but I don't think there's any question it is going to happen. It's just a matter of whether it's going to happen in your lifetime or mine.
Right.
And then all of the other man-made reasons for immigration, which, span the gamut. We're seeing a lot of that right now, too. And, housing is a fundamental human right. We sort of put those pieces together and look at something like a material like bamboo, which is pretty much available throughout the tropics, period. So bulk of the planet has immediate access to it.
This is very true. There are in excess of 1,250 species worldwide of bamboo, although fewer than 100 species have potential for their structural use. The interesting thing about bamboo is that it's so much more easily grown in these tropic regions compared to what you would have in terms of a time frame whenever you are trying to cultivate and crop trees. Bamboo can actually cultivate the appropriate strength requirements within 3 to 6 years of growth.
And it is a very viable alternative to a much lower energy potential input to wood or to even light gauge steel, and alternatives to masonry construction in a lot of areas as well, having all sorts of other potential advantages. We first came across, and we first started working with bamboo years ago when we were looking at seismicity in the Himalaya. You have very, very steep slopes. A lot of them are unstable, and everybody's building masonry and concrete construction on them. So you put very heavy loads on a not so stable slope that may be 45 degrees quite reasonably in foothills. It just doesn't work. You read the newspapers in Darjeeling, buildings fall over all the time. Bamboo is a lightweight construction. It's safe. And in the earthquake, 2005, I think, in Sikkim, light frame construction fared fine. There's no problem. Masonry construction, concrete construction, all sorts of issues associated with that. And so it addresses that fundamental human right. And you've got to recognize the UN recognizes safe shelter as a fundamental human right. Mm-hmm. I'm not just making this up. When you extend that type of argument, you look at vernacular materials, you look at what makes sense and what has gone before. And so we're very much learning from the past. Other areas of the world where bamboo clearly, I'm using bamboo as an example, are clearly not an option. Earth construction absolutely is. You go to the southwestern United States, adobe is a very rational, very easily built approach. And there's a range of earth construction possibilities, whether it's unfired brick, which a lot of people question the durability of it, but it's been proven to be durable. We who grew up in the West don't know some of these great cultures. We think about the Romans and the Greeks, and maybe we know a little bit about the Inca and the Maya and whatnot. But some of the early African cultures, Great Zimbabwe, is a fantastic site. It's unfired earth brick for the most part. It's been standing around for about 800-900 years. Wow. And we just don't recognize that. You look at the city of Bam in Iran, which was devastated by a massive earthquake a number of years ago, but is earth construction essentially. You look at the 8 and 9 and 10-story residential construction in Yemen, which is earth functioning. And so this works. There's a good history to it. Engineering, we're coming along and looking at things like rammed earth, which is sort of a hybrid, I suppose, of earth. And sort of now you're placing it in forms in the similar way you might do with concrete. And you're literally placing it in and ramming it in, consolidating it. You might add a very, very small amount of cement to consolidate it, 1-2%. So much, much less than you would be using for concrete. And these are beautiful structures. They come out looking, because you get that sort of layering of the earth, you take the forms off. It's absolutely beautiful. And they work. One of the most impressive rammed earth structures that I've seen is a lecture hall or a small concert hall in Wales. So not exactly a dry desert environment.
Yeah.
And so there's a lot of these materials that come along. There are other lightweight types of materials out there. I had on a committee for a PhD at Carnegie Mellon University, and this was an interesting study looking at earthen construction and recognizing, so earthen construction has other advantages in terms of heat and insulation and whatnot, but actually building hybrid types of construction where it doesn't have to be 100% adobe. Maybe the west wall should be a little bit different built than the east wall, and certainly the north wall, to take advantage of sun, to take advantage of heat storage and whatnot. And there's nothing that would stop that. There's a lot of other sort of innovative materials out there, but I think that the ones that are going to, that we should be focusing on are the ones that are readily available, the ones that have a vernacular history. Mycelium is one of the things that's seeing a lot of interest right now. And mycelium is essentially a spore. It's a mushroom.
Yes.
And it can be grown into forms, and architects love this because they can do almost anything they want with it. But there's essentially no history to it. But we have been living in earth construction for thousands of years. We've been living in bamboo construction probably for thousands of years, timber construction. Heavy timber, which may not seem like a particularly sustainable approach, with some of the technologies we're looking at now, being able to use timber in a much rawer form where we can sort of pick and choose the parts that we need, because now we can inventory entire parts. And there's some fascinating structures that we put together this way. It's really nice to build a big one-off to show what can be done, but we really need to be thinking about these kind of residential, how are we going to address and house, 7 billion people on the face of the planet,
Right?
Recognizing that a lot of this is going to be new.
Yes, I fully support this claim because, in essence, for this episode, we're talking about what materials we need to focus on in terms of the built environment or our infrastructure. Because a lot of these materials, like mycelium or graphene and self-healing concrete or translucent wood, whatever it might have you, I mean, there's a lot of different things out there that are being progressed in terms of within a lab or within a standalone example. But we haven't seen that total takeover in terms of the market. That's why you see so much concrete is still being out there. It's because it's being produced on a level in which none of these materials can compete with currently. So the stuff that Dr. Harries is mentioning within this podcast are materials that he feels and are upcoming, in which they can really make an impact on our infrastructure sector.
Well, the other thing that a lot of these vernacular type of materials, and I'm using that term a little bit incorrectly, I'll admit, offer also is that connection to the construction.
Just to define vernacular materials or vernacular architecture, in general refers to the informal building of structures through traditional building methods without using the services of a professional architect, and it is the most widespread form of building. So areas rich in trees will develop a wooden vernacular, while areas without much wood may use mud or stone. Vernacular, almost by definition, is sustainable and will not exhaust local resources.
You and I could probably build a nice 2x4 shed. We could build a little nice recording studio out back for you and stuff like that. Could we do it with concrete? We could. And we could do it with steel, but we're probably not that good with it. But one of the things with grabbing some of these, whether it's bamboo or earth, they're a value skill. And so they also produce an economy internally within that community, which has a particular benefit. If you build or you have a hand in building your own house, there's more of a sense of ownership. And I'm not talking about a financial sense at that point. You did something, you built it. And so that's a piece of the puzzle as well, I think. And we have to have something that people are going to be comfortable with. We have a very bad habit of deciding that this is how we're going to fix the housing problem in a certain area. And I'm not going to take any particular examples, but then we come in with these pre-designed, these wonderful prefab things that are economic, they're cost efficient and the whole thing, but they don't suit the culture of the people being asked to use them, who kind of look at them and say, we don't live that way.
Right.
And we'll often skip that aspect. And so going to these vernacular materials actually can bring people back, for right or wrong. And I don't want to pass any judgment on this. There is internally in China right now, there is a large movement toward rehabbing small villages. I don't exactly know why. My guess is because most people were moving out to the cities and the small villages were dying. And you still need the small villages for farming, things like that. And a lot of this focus has been on more traditional materials and more traditional architecture, not just putting up a new cinder block house, but actually coming back to bamboo. And some of the best bamboo architecture going on in the world right now. Fascinating stuff is coming out of China, really aimed at recognizing what a community needs to be a community. And that's a piece that we miss sometimes when we talk just about materials or just about building square things.
Definitely. It then just ties into, the psychology of the people. They have to live there. The people who design it don't have to live there. The people that, have to inhabit there, they have to see it every day and deal with it. And you're totally right in terms of they wouldn't know how to fix it. It doesn't jive with how they've done it for their lineage.
Well, and we need to recognize, you and I come from a society where we're going to go out, and look at houses and buy a house that we like. We're very privileged in that sense. We have choice, and we are I don't know, we're the 1 or 2% that really do have that choice. And materials can really make a difference in how, earth construction is a very warm, in the sense it's a nice place to live if your culture and if that's sort of part of the thing. Wood construction, people love living in wood. Look at my dad, everything's fake wood grain stuff, right? Because wood is warm and comfortable.
Right.
We know this. Sadly, there is exposed concrete in here, but we all wish there weren't, right?
Yeah.
So that's also part of what we have to look at. And I think that we're finally also recognizing there are building materials that can also serve other functions. And I'm primarily thinking about heating and cooling and environmental control. Steel does not do that. Let's face it, steel just transmits heat. Concrete can do it depending on the design. If the designer knows what they're doing, you can use concrete to some extent, but it also hurts us. We know that the heat island effect is almost entirely a function of the amount of concrete that we have around us. A lot of these other materials are coming about for other reasons now. We built with steel and concrete because they're strong and they're inexpensive. Now we're looking much more seriously at, looking back again at timber and heavy timber, earth construction, other things like that, because they have other properties that we need to start valuing.
Right. And we're also exploiting some cross-laminated beams. So with timber or with bamboo per se. What's your take on that?
Well, laminated and cross-laminated materials are just really an efficient use of material. Yeah. So if I need to span a long span with timber, either I can cut, as they're doing for Notre Dame Cathedral right now, they're cutting 300-year-old oak members. Now, there's a good reason for that, and there's good historic and architectural reasons for that. But if I want to make I got to go cut a 300-year-old oak tree, or I can cut good harvested wood that's maybe been growing for 10 or 15 years on a plantation, assemble those pieces into a bigger piece. So all it is really a much more efficient use of material. I can build a beam of pretty much any size or a column of rational size using exactly the same timber that I might to produce 2x4s to go sell at Home Depot.
Right. And they're now, because of these cross-laminated timber members, we're able to design larger, more taller wooden structures, which we were talking about building. What was that? Scandinavian.
Well, we built a number of 20-story timber structures. There's a few out there today. In fact, the tallest, I believe still the tallest one, maybe have changed. Certainly there's a 20-story structure in Vancouver. There's another 20-story structure in Norway that I'm aware of. A number of ones that are in between. There's one in Milwaukee.
Oh, really?
It's not 20. It's certainly, I believe, still the tallest. Better be careful. It may not be the tallest in North America anymore, or in the United States, because there's also one, there's planned, and I don't know where it is, out in Pacific Northwest. But yeah, there's a tall timber. It's on a concrete pedestal, but I want to say there's 15 plus stories of timber above the concrete. Basically, there's a parking deck. And, you get back into codes. My guess is they just could not convince the local code officials to allow a timber parking garage. And I can kind of understand where that might have been coming from. So it's very viable. There are people with plans. A friend of mine who has been referred to as an architect who's rather mad has a plan for an 80-story structure in London. Now, it's not likely to be built, but there is a viable plan. As I said, I believe it's about 60 stories in Scandinavia. There's no technical problem with it. And we can see there have been a few smaller structures, 3, 4, 5-story structures, even around Pittsburgh. You can walk around it and you can find some cross-laminated floor system. But it's a very nice construction process too, because you can build a slab, a floor. Typically, they're going to be made up of 2-bys. So they're going to be in multiples of 1.5 inches.
Mm-hmm.
So you might have 3 of them stacked. You might have 4 of them stacked. For a large span, you might get 5. They come in big panels. If you can ship it, you can get it to the site. So they're generally 8 feet wide, but about as long as you need.
Mm-hmm.
You pick them up, you put them there. They're a floor. They're an instant floor. A workman can safely work right on top of them as they're installing them. And that's it. Both the top surface and the bottom surface are exposed, which is kind of nice for the flat below and the flat above.
Mm-hmm.
And then the columns themselves are also timber and usually left exposed.
Like you said, it's more of a warm environment rather than looking at concrete and steel
Absolutely.
And members.
So what cross-laminated timber brings us, or what laminated timber, glue lam, and we're doing the same thing with bamboo. It just basically allows us to use more marginal material, the offcuts, the scraps.
Yeah.
Which works well when we have the sort of tree plantation aspect of it. I got the wrong word right. But because our harvesting of timber is very well managed in North America and Europe, we can do this because we can get a large number. If my process needs pieces that are, straight trunks that are, let's say, 12 inches in diameter, I can get those, and I can get them by the boatload.
Mm-hmm.
And then I can do this. So it allows me to really utilize material to the greatest extent possible.
Awesome. Well, thank you. So we're going to stop here for our commercial break, but when we return, we will discuss the roles in which materials have with respect to climate change and the future. So stick around to find out. We are back here on Woke Talk Podcast for the final segment, or Materials of the Future. I'm your host, Sam Stanford. I have with me Dr. Kent Harries of the University of Pittsburgh. So I want to turn it over to you, Dr. Harries, and beg the question, how can we alter our infrastructure to slow climate change with materials like the ones we discussed in segment 2? And if you have anything to expand on from there.
Well, I think we touched on it a little bit to the extent that we think about materials differently than we once did. At one point, steel and concrete and other materials were selected for their strength, maybe for their durability as well, and their low cost. But we recognize if we think about a building, not a bridge, not a roadway, but a building that's intended for an office or residence, the cost, and whether we talk about cost in terms of economic cost, of dollars, whether we think about it in terms of CO2 equivalent, we think about it in any other types of costs associated with climate change. We touched on, or we also kind of neglected earlier, water is another cost and the need for this. The use phase of a building by far exceeds the energy use cost of the construction of it. And so the material itself is not as important to the behavior of the structure as the properties that the material imparts to that structure. And so what I'm getting at is materials and systems that insulate well, that retain heat during the day, dissipating it out at night. Earth and construction can be designed very well to do that.
What Dr. Harries is talking about is the phenomenon of time lag. So whenever you have sun rays hitting your house at 7 a.m., if it has a 7-hour time lag based on the material that's within your walls, it's going to take 7 hours for that heat to propagate through the materials of your wall and enter into your house. So if you approach the material side of it correctly, you can end up having a warm, cozy night and then a cool operating day.
Taking advantage also of different architectural forms, chimney type effects and whatnot can help. But if we start thinking about using materials for other reasons than simply strength, I think that's what we're going to see.
So you would say more like tailoring it to the climate in which you're in.
Well, recognizing that there are other reasons to select materials, and certainly when we start getting into climate change, our desire and our need to a great extent to regulate the climate that we live in, that we want it to fall between 65 and 75 degrees, 365 days a year, that is what's impacting the climate. Right. That's where our biggest cost lies. And so if we can select materials, put them together in maybe somewhat different ways, that will allow us to do that inexpensively or potentially with no expense whatsoever, taking advantage of the environment around us, that would be great. Now, that said, we have our cities. We're not going to demolish them and rebuild them all in some other form. And so there's a lot of pieces to this. And so there's a lot of other unique materials that maybe I'm not aware of that will be integrating with existing infrastructure in order to do this as well. We all know that we can blow more insulation into the walls of our house, and that's generally a good thing. But are there more efficient insulations? Maybe I should be growing mycelium in the walls of my house because it might be better. I don't know. And so I think that when we talk about construction materials, we tend to get locked into stress and strain. We tend to get locked into strength. What can this do for me? And we need to start thinking about other aspects of that material and the trade-offs then. I mean, there's no question. I've spent a little bit of time talking about earthen construction. Earthen construction is great, but there is more maintenance involved with it. There's no question in most environments, maybe not out in the middle of the desert. So, well, it could be because of course it erodes due to wind. And so things change as well. Now there's a lot of maintenance involved in the buildings that we have today. But as a rule, that's one of the other advantages of, our normal steel and concrete is that they are generally a lower maintenance, much more durable product over the types of timeframes that we think about. Where we may be building a larger building for 75 to 100 years, we may be building a typical residence with the mindset of a 30 to 50 year life. And so those need to come in. But the other side of this, and kind of talking about this offline initially, is there's the supply and the demand side of the equation. We're talking about materials. Materials are the supply. The demand is what I'm asking. And do I need a 4,000 square foot house and all the materials that is going to use? And then I'm going to heat it. I'm going to cool it for the next 35 years versus would I be happy in a 1,200 square foot house? And more or less my energy use through time is probably going to be a linear function of the area, right? I mean, given that I'm always going to have 8-foot ceilings because I don't want to, I'm not going to crunch the volume down. My family and I, we spent a year in Great Britain and we lived in a 750 square foot flat and we didn't kill each other. And that's much more common pretty much everywhere else in the world outside of Canada and the United States, pretty much.
Now, let me expand on this a little bit. So houses here in America since 1960 have actually doubled in square footage from just a little bit over 1,000 square feet in 1960 and to today, or according to the U.S. Census of 2020, was 2,687 square feet. Now we're also living with less people. We went from an average household occupancy of 3.33 people in 1960 and have decreased all the way down to 2.53 in 2020. Lastly, it is important to note that the United States is actually ranked second behind Australia in terms of having the largest square footage households.
And so looking at that demand side, we can put a much bigger dent into our use of non-renewables, whether it's for construction or energy, by addressing the demand side, by curbing our demand, rather than re-engineering and jiggering a little bit. And yes, I mean, we can improve concrete, and we can improve construction material, but if we're still building 4,000 square foot homes, we're not addressing the real drag on issues of climate change or sustainability, or however you want to describe it.
That makes a lot of sense. So to change gears here a little bit, what do you think we could do maybe on the building code side to maximize the performance and minimize the use?
I think we are doing it. I mean, the transition over the past couple of decades where we have the international codes series, we have an energy code. We have also, I guess, the plumbing code gets involved in that. We do have codes that are evolving to slowly address these things. The problem, one of the problems always, particularly in a Western code environment, is that we tend to move at glacial paces. Construction industry is not one that embraces change. I'm going to get in a lot of trouble for saying that, but that's okay because I can back that up with fact. We recognize the need, but it takes time because you're also, in some senses, you can't go reinvent the wheel,
right? Because
you've got industry based on it. We're having sort of that discussion right now, going away from construction, but one that a lot of people can kind of get a handle on is with electric cars. We have an infrastructure that deals with gasoline vehicles. How do we convert that to one in which 50% of the private cars on the road, and maybe even more of the trucks, are going to be electric. And yeah, sure, the ranges will get better, but maybe some of the best ones can go about 200 miles on a charge. To me, that implies also a different way of living. Well, my neighbor who goes up to his cabin, which I know is a little bit more than 200 miles away. So what's he going to do?
But I mean, you had the same problem whenever it was horse and buggy and cars, or whenever you had a mass amount of people that were like, well, we have cars, but now we need gas and we need gas stations. So now we got to put them all over the place. I think it's just the time. It's the time lag.
There is, but there's also something different because we're evolving here, or we're not evolving so much as we're going to have a dual system. I mean, assuming we have 50% electric vehicles by 2050, 2040, 2050, which is an admirable goal. Well, we still have to have both sets of infrastructure out there.
True.
Where I live, I have no garage, I have no back alley, and my parking is on the far side of my street. Today, I couldn't own an electric car if I wanted to.
Very true.
I guess I could negotiate with my neighbors to plug my car in and pay part of their electric bill. There's a slow evolution just by necessity. You've got to retool masses of industry because demand doesn't require that. Demand, on the other hand, requires a paradigm shift. You're not going to tell everybody, well, guess what? You're all going to live in 1,000 square foot apartments from here on in. That's just not going to happen. But to some extent, it's logistically more possible.
Fair point. Those are all actually great points. And I know that, even with learning curves and the exploitations of failures will continue to be our allies moving forward. That'll help us strengthen these building codes and introduce more effective materials in these situations that best suit their profiles, so to speak.
Unfortunately, we're getting to a point where the problems are accelerating faster, and I'm not certain that we can rely. I'm not certain I really want to rely on learning from failure from here on in, because that is also a slow process.
Oh, yeah.
And I'm not entirely convinced we can afford to continue to learn from our failures. I think we're seeing our failures maybe tipping a little bit too far, and we need to do this. We talk about construction materials. They are one piece of that puzzle, partially from their material perspective, and also partially because they're just a massive huge amount of energy goes toward constructing our built environment. The use within our built environment then is more of a design issue, is how do we get that? I mean, the best way to cut your air conditioning demand by 50% is to cut your living space by 50%, right?
Right.
I mean, that's math. I'm not advocating this necessarily. I mean, I got a 7-year-old. I want to be as far away sometimes as possible. But these are the decisions that we ultimately are going to have to take.
That makes sense. My final question for you, and it's kind of a lightning round one, but do you think there is hope to minimize the footprint and increase the quality of our structures?
Absolutely. And I think we're doing it. We're seeing earth construction codes show up in North America. I believe it's New Mexico has one already. Adobe is included in the International Building Code. It's not the best. It needs some work, but it's getting there. If I were of the sort, and maybe now that COVID is around, maybe I will get a second home somewhere rather than all the travel that I do. If I was building a second home in Pennsylvania, I'd probably start looking at hay bale construction, straw bale construction, or something like that, because I think it's really neat. It's got some nice architecture. I like it. And it's an interesting answer. And I could use it as an experiment and see if it works.
I actually presented on that in your class. So I might do a little spin-off episode on that just to kind of explain some things on that, if anybody's interested.
Straw bale construction has, I think one of the issues, and I think you even brought this up in your presentation, was it probably doesn't have as broad a geographic, and it's probably much more limited than some of these other ones.
Right.
Potentially. That's what I would do. If I had a piece of land within the radius of my electric cars, which I don't own, range, I would probably try and do straw bale construction if I could convince the local authority to let me do it.
Oh yeah, and I feel like you'd be the one to be able to do that.
I'll try.
Well, hey, I appreciate this. This was awesome. Thank you for being on the show. It's always a pleasure talking to you.
Cool. Well, thank you.
That is all for this episode of Woke Talk Podcast. Now I'd like to give a big shout out to my guest star, Dr. Kent Harries, for sharing his wealth of knowledge and vast expertise. I would also love to mention my amazing team here at Woke Talk Podcast for their collective efforts to make this show happen. And then finally, I would like to thank all of the people who listen and support this show. It has been an absolute pleasure to interact with all of you and provide relevant information for your consumption.
As always, if you have a question or a content suggestion or want to be a part of the show, please reach out to us on social media or send us an email at woketalkpodcast@gmail.com. Now, to wrap up, we hope you take away important information in regards to materials that we have grown into massively utilizing in our built infrastructure, the materials that are up and coming in my field of work, and then what we can do in infrastructure to help attack climate change moving forward. We hope that our material choices, building codes, and design will make an impact to protect future generations. So to find out more information about up and coming materials and the progression of building codes for the future, listen to the International Code Council's podcast called ICC Pulse. You can find the ICC Pulse on the ICC website, www.iccsafe.org. If you are a reading or visual learner, Dr. Ken Harries published his second edition of Non-Conventional and Vernacular Construction Materials in 2020. It is a perfect piece for learning more about these materials we addressed and much more. As always, I would like to mention that Woke Talk Podcast would like to encourage you to invoke change in our society and make an effort to make this world a more sustainable place. We need leaders to protect our ecosystems for the survival of future generations. So just remember, change does start with you. And once again, thank you all for listening to Woke Talk Podcast. I'm your host, Sam Stanford. And as always, stay woke. Woke Talk Podcast would like to give a shout out to Anchor by Spotify for sponsoring our podcast, along with Ben Sound Music for providing our show with intro, outro, and advertisement background rhythm.